All right, we'll look at our Chapter 6 review. As we're looking at problem number 1, we'll go over a review of our trig function values using right triangles. So you see here we have a right triangle ABC, where angle C is our 90-degree angle. Of course, angles A and B are acute angles that measure between 0 and 90, because we know all three angles in a triangle must sum to 180 degrees. So if angle C is 90, the other two are going to have to sum to 90. So they would have to both be between 0 and 90 for that to happen. It says find the sine of angle A. So let's start with the sine of A. And the sine of angle A, using the right triangle, sine is evaluated by the opposite side of angle A with respect to the hypotenuse, the ratio of opposite to hypotenuse. So with A, right, here's my opposite side. Right, of course, here's the hypotenuse. So as we go through that, we have 16 over 20 for our function value. And, of course, need to reduce that. So let's go ahead and divide out our common factor. We know 4 will divide into both. So as we reduce, we get a function value of 4/5 for sine of angle A. With that said, it wants to find the cosecant. We could do that too. Cosecant of angle A would be the hypotenuse over the opposite side. Again, these are reciprocal functions. So that would be 20 over 16, which reduced. So we divide out our common factor of 4. We get 5/4 for our function value. You can see those are reciprocals of each other. All right, cosine. What's the cosine of angle B? Cosine is defined as the adjacent side to angle B over its hypotenuse, with cosine's definition with respect to right triangle. So what's our adjacent side to angle A? Right here, the adjacent side, right, is 12 units in length. So there's the adjacent side. As we go through, we got 12 over 20. As we divide out our common factor of 4, we got 3/5, right, for our function value. And now for its reciprocal function, which is secant. And keep in mind this is angle A, not B. Secant of angle A would be hypotenuse divided by adjacent, right? So reciprocal cosine. Cosine is adjacent over hypotenuse, secant's hypotenuse over adjacent. So that would be 20 over 12. As we divide out our common factor of 4, we get 5/3, reciprocal of cosine. And to finish off angle A, let's go ahead and do tangent's function value. Tangent with respect to a right triangle is opposite over adjacent. So our opposite side of angle A is 16 units in length. Our adjacent side, angle A, is 12 units in length. Our greatest common factor is 4. As we reduce, we get 4/3 for our function value. And with cotangent of angle A, be the reciprocal. So it will be the adjacent side over the hypotenuse. So it'll be 12/16. As we divide out our common factor of 4, we get 3/4 for our function value. And now let's go to angle B. So with angle B, all right, let's start with it. What's the sine of angle B? So with angle B, now our opposite side, right, would be 12 units. And our adjacent side would be 16. So with angle B here. So adjacent, right, and then, of course, opposite. So sine of angle B, defined as opposite over hypotenuse. That would be equal to 12/20. As we reduce, we divide out our common factor of 4, get 3/5. And with cosecant of B, we get, of course, hypotenuse over opposite. So we get 20 over 12. And as we reduce that, dividing out our greatest common factor of 4, we get 5/3 for its function value. All right. And if you look, these two angles A and B, are complementary, right? We know those two must add to 90. because angle C is 90. So if you look back at cosine of angle A, we had 3/5. Well, sine of angle B is 3/5. If you remember our complementary angle theorem, cofunctions like sine and cosine, like tangent and cotangent, like secant and cosecant, they hold the same values with complementary angles. So again, you'll see that with these. Let's go to cosine. Cosine of angle B, again, adjacent side over the hypotenuse. Adjacent side to angle B, the side next to it is 16 units in length over the hypotenuse, which is 20. Dividing out our common factor of 4, it reduces down to 4/5. Alright, so cosine of B is 4/5, which is what the sine of angle A was. Again, they're cofunctions, complementary angles. And with secant, its reciprocal function. Secant of angle B, we've got hypotenuse over adjacent. So we've got 20 over 16. Dividing out our common factor of 4, we get 5/4 reciprocal. And to finish it out, we got tangent of angle B, opposite over adjacent. So we've got 12 divided by 16. And reducing that, dividing out our greatest common factor of 4, we get 3/4. And with cotangent of angle B, we're going to get the reciprocal of that. We're going to get 4/3, right? We take the adjacent side, divide it by the hypotenuse, 16 over 12. Dividing out our common factor of 4, we get that 4/3. So a little review using some right triangle trigonometry. All right, going to problem number 2. It says if cosine of angle theta is equal to a function value of 8/3, what's the cotangent of angle theta? So let's take theta. Now, with the function value being positive, we could think about a acute angle, a quad 1 angle. I'm going to use right triangles to show it. So remember with cosecant. So again, we're given cosecant of theta, value of 8/3. So remember, that would be hypotenuse, right? It's reciprocal sine over opposite. So let's go ahead and draw our right triangle, given that function value. So let's draw in a right triangle. So triangle, here's our 90-degree angle. All right, and I'm going to let theta be this acute angle. Hypotenuse, longest side in this right triangle, side opposite 90-degree angle, is 8 units in length. Opposite side of theta is 3. Right, so there's the opposite. There's the hypotenuse. So again, using cosecant. They gave us cosecant. Now what we don't know, which is what we want to go find, is the adjacent side. So we need to find x. Right? So we'll do that by using the Pythagorean theorem. So we know the relationship of the 3 sides in any right triangle is the square of the hypotenuse. Hypotenuse squared, 8 squared, equal the sum of the squares of the 2 legs, x squared plus 3 squared. And as we simplify down, that's 64 equal to x squared plus 9. And as we solve that for x, we'll subtract 9 on both sides, we get 55 equal to x squared. And now we'll take the square root of both sides. If you want, put it in a different color. Principal root, since we want x and we have x squared. That implies the square root of 55 is equal to x. Now again, irrational number, we're going to leave that as a root. I don't want a decimal that I'd have to round. All right, so I'm going to leave the exact. So my adjacent side, so its length, square root of 55 units. So now we can find cotangent. So cotangent of angle theta, by definition in a right triangle, is the adjacent side of theta over the opposite side. So the adjacent side, square root of 55 units in length, and the opposite side is 3. So we end up with square root of 55 over 3 for our function value. So there's cotangent of theta. Okay. Problem 3. Without using a calculator, give the exact trig function values with rational denominators. So make sure you rationalize any roots and denominators. Now these are all special angles. 30, right, 60, 45. Our special angles coming into play. So yeah, we do not need a calculator. We've been spending time with these throughout the whole chapter, and by now you want to know these function values. So for example, the cosine of 30 degrees, we want to know that equals the square root of 3 over 2, right? And if you want, you can prove it using right triangles, using the equilateral triangle, dropping in your height, which bisects your 6-degree angle, makes your 30, 60, 90 right triangle. And again, labeling the sides of length 2. When it bisects the base, it makes one of the legs 1 unit, and your other leg will be square root of 3 units. So you can prove that with equilaterals, right? Or you can even go a little bit further and use a unit circle. So a couple ways to do it. So you could use right triangles. So if you need to, just a quick review. I'm going to draw it in just to show you where it comes from. All right, equilateral. So with equilateral, we have 3 sides the same length, 3 angles being the same measure, and I will let these lengths be 2. And when you drop in that height, right, you drop that perpendicular, right, you form your 2 right triangles within that, and that bisects space into 2 lengths of 1 unit. And then to find the missing leg, use the Pythagorean theorem. 2 squared equal x squared plus 1 squared. So 4 equal x squared plus 1. As you subtract 1 on both sides, 3 is equal to x squared. So you take the square root, x equals square root of 3. So that means cosine of 30 degrees, so remember this is a 30-degree angle. That's a 30-degree angle, so you can see exactly where that comes from, right? Adjacent over hypotenuse. So you can prove it right here in the equilateral triangle, right, with 30. You can do all of them. All right, you can also, a quick way to do it is your unit circle. So a couple different approaches, and I'm going to write that down too. So unit circle approach, right? Right, we know at 30 degrees, we have the ordered pair, square root of 3 over 2, 1/2. There's the x-coordinate, there's the y-coordinate. And we know cosine is equal to the x-coordinate with the unit circle approach, square root of 3/2. So again, different ways to do these, either with a right triangle with equilateral or using unit circle. So these should be quick and easy. Now with respect to that, let's go to the sine of 30 degrees. Sine of 30 degrees equal to 1/2, right? That's the opposite side over the hypotenuse, right? If you look at 30, or you look at it using the unit circle, right? There's your y-coordinate. So y-coordinate right here, 1/2. Sine of 30 degrees. All right. Let's go to the next one. We've got the cosecant of 30 degrees. Cosecant 30 degrees is going to be the reciprocal, right, of that. 2 over 1, right, which equals 2. So again, remember these are reciprocals. So reciprocal function. All right, let's go to the next one. Let's look at 60 degrees. What about the cosine of 60 degrees? If you want to look at your equilateral triangle, right, the adjacent side's 1 unit and the hypotenuse is 2. Cosine of 60 is 1/2, which also, if you look at complementary angle theorem, same as sine of 30, right? So again, different ways to evaluate that. And it's also on the unit circle approach. So let's use that, and we'll go here and plot that point. Unit circle approach with a 60-degree angle. We have a ordered pair of 1/2, square root of 3/2, x-coordinate, y-coordinate. So cosine of 60, right? 1/2. So using that. If you want to do the sine of 60, let's write the sine of 60 degrees. Sine of 60 degrees would be square root of 3/2, right? It's the y-coordinate. So again, there's the x-coordinate, right? There's the y-coordinate, right? So again, you can see then the y-coordinate right here. All right, how about cotan of 60? Cotan of 60 degrees. We know cotangent on the unit circle is x-coordinate over y-coordinate. So using the unit circle point, we got 1/2 divided by square root of 3/2, which is 1/2 times, you got to reciprocate, times 2 over square root of 3. And here's what they mean by rationalizing. Go ahead and get rid of that square root in the denominator. So we'll rationalize that. So we end up with the square root of 3 over 3. There's a cotangent of 60. So cotan of 60 degrees. X-coordinate divided by the y-coordinate. Right, unit circle approach. All right, let's go to 45 degree. I've done one with 45. All right, how about, let's put it over here. 45 degrees on the unit circle. We've got coordinates square root of 2 over 2. Square root of 2 over 2. So that implies what? That implies the sine of 45 degrees equals square root of 2 over 2. You can also use the isosceles right triangle to prove that with right triangle, letting your legs of your two congruent sides be 1 unit. And then you find your hypotenuse, which will be square root of 2 using Pythagorean theorem. And you can prove these values with that. Of course, cosine of 45 degrees, square root of 2 over 2. So again, you got your x-coordinate, you got your y-coordinate. There's x-coordinate, there's y-coordinate. And then the tangent, what would the tangent of 45 degrees be? Tangent is y over x, right? Square root of 2 over 2, divided by square root of 2, so it equals 1. And secant of 45 degrees, just to finish it off, that's equal to 1 over the x-coordinates, reciprocal of cosine. So that's 1 over the square root of 2 over 2, which is equal to 1 times 2 over square root of 2. And as you rationalize, right, so we multiply by square root of 2 in the numerator denominator, right, what do we end up with? We end up with 2 square roots of 2 over 2, where the 2's divide out, and we end up with a value of square root of 2. Yeah, the secant of 45 degrees is square root of 2. But again, I used a unit circle without using a calculator. Use unit circle approach. By far the easiest way to get used to your values. Right? So we'll make that note. So unit circle. So you got your ordered pairs, right? Ordered pairs on the unit circle. So 30, 60, and 45. All right, let's move on to problem number 4. It says find the acute angle theta to the nearest hundredth, 2 decimal places. So we're going to find theta. So the sine of theta holds a value of 0.5182. Well, if we want theta, that implies theta equals sine inverse of 0.5182. So inverse properties. So again, we got to use inverses. All right, got to swap it out. Now, with that said, we want a degree measure. So let's go to our calculator. All right, make sure you're in degree mode. All right, we're going to put that in there. I'll put it in here on a calculator. Now, in my mode, right now I'm in radians. So I hit the mode key. I'm going to go down here to degrees and hit the enter button. Make sure you highlight degree. And then second mode, which is quit. And now we can type it in here. So you're going to need to hit the second button. And above sine is sine inverse. So we want a sine inverse of 0.5182. Right, hit the enter button and end up with a degree measure of 31.21 degrees. So 31.21 degrees is theta. There's my angle measure. Yeah, make sure you're in degree mode. I'll make that note. Now I like the next example. The two would be better test question. Just because both of these are done with our calculator. And at least we have to do a little bit of work on this one as far as using the shortcut keys in the calculator. Now we're given secant. So what I'm going to do is rewrite it. Let's use cosine. Cosine of theta would be 1 over 6.27. So remember, these are reciprocals of each other. All right, reciprocal functions. So rewrite it as cosine. And now, right, we can find theta easily with our calculator. So we'll swap it out. So theta will equal cosine inverse of 1 over 6.27. So we're ready to put in our TI. So let's go type that in and see what our function value is. So I'm pulling up our calculator. So we got, second cosine, second button and cosine, and then 1 over 6.27. And hit enter, and I get 80.82 if we round to the nearest hundredth. So approximately 80.82 degrees would be that angle measure. So rewrite as cosine, all right, then the inverse property. All right, so I'll make that note. And that'd be the same thing if we were doing cosecant, we rewrite as sine. If we were doing cotangent, rewrite as tangent. That way you can use those shortcut keys to help you. Now, problem number 5, these should be quick and easy. Make a little note. Exact angles, these are our special angles. All right, these are our 30, 45, 60 degree angles. All right, we should know the sine of theta. If square root of 3 over 2, right, we should know that theta, right, holds a value of 60 degrees on this one. Right, this is the y coordinate at 6 degree on unit circle. All right, so you can get your unit circle out if you need it. So with your special angles, let's write down those ordered pairs. At 30 degrees, we have square root of 3 over 2, 1/2. At 45 degrees, we have square root of 2 over 2, square root of 2 over 2. And at 60, we have 1/2 square root of 3/2. Right? X coordinate, Y coordinate. That's our answer. Now, yeah, you can put in your calculator if you need to, but you don't need a calculator. So, or with calculator, right, theta is equal to sine inverse of square root of 3 over 2. So let's go to our TI and type that in. So second sine, square root of 3. So second x squared key divided by 2. Close it, and there's 60. We're in degree mode, so it's going to give us that 6 degree measure. So yeah, you could use calculator, but we don't need it. Now with cosecant, the square root of 2, I know that's 45 degrees. That implies theta is 45 degrees. Cosecant. Now if you want to do it with the calculator, I would rewrite it. That's sine theta, 1 over the square root of 2, which implies theta is equal to sine inverse of 1 over square root of 2, which is equal to 45 degrees. So you can type that in your calculator if you need to see it. All right. So we go read our calculator. Second sine, right, 1 divided by the square root of 2. All right. We're going to get that 45 degree measure. All right. But when I see square root of 2, I'm already thinking 45 degrees. Special angle. X coordinate, Y coordinate. X coordinate, Y coordinate. Let's go ahead and finish it out. Example C. Example C, I know that theta, the square root of 3 over 3, tangent value, and that's going to be a tangent of 30 degrees. Right? And you can look at it on the unit circle, right? And you can put it in your calculator if you need to. So So theta would equal tan inverse of square root of 3 divided by 3. Right, which will give you, again, the 30-degree measure with that one. So again, that's easy problems, the angle measures with these special angles. We don't even need a calculator, of course, to find these measures, but if you need to put it in your calculator, you can. All right. Solving right triangles. Moving on here to problem number 6. And 6a, they give us side C, which is 21 units in length. They give us angle B, which is a 21-degree measure. And it wants to solve it. So what we're trying to do is find the unknowns. We want to find angle A. We want to find side A. And we want to find side B, right? That's what we got to do to solve that triangle. So to do that, let's use some geometry here at the beginning. Let's go ahead and find angle A. All right, what does it equal? So we know all three angles must sum to 180 degrees. So it's 180 minus the sum of the two that we were given. So that's equal to 180 degrees minus 111 degrees, which is 69 degrees. So there's 1/3 of my solution. So using a little geometry. All right, now let's find side A. All right, to find A, I'm going to use my right triangle trig. Let's use the given angle. So let's use cosine. So with that said, all right, I know the cosine of 21 degrees equal to adjacent. Right, here's the adjacent side. Here's the hypotenuse, right, which we're given. So adjacent side is my unknown, A, right, over the hypotenuse, which is 21. And now as I want to solve that, right, all I got to do is multiply both sides by 21, right? Now we can divide those out. So as we times both sides by 21, we get the equation like we want it. We get 21 times the cosine of 21 degrees equal to A. All right? So we're going to put that in our calculator. What's 21 times the cosine of 21 degrees? So in our TI, 21 times the cosine, we know we're in degree mode, so we're good when we type in 21. I get 19.6, right, if I round to the nearest tenth. All right, so that implies A is approximately 19.6 units. 21 times the cosine of 21 degrees. And to find B, you could use trig if you wanted, or you could even use the Pythagorean theorem. A couple different ways to do it. But say we're using our trig functions, we could do B using sine, right? What's the sine of 21 degrees? It'd be equal to the opposite side, right, which is B, over the hypotenuse, which is 21. And as we solve that, right, we multiply both sides by 21, right, and then we'll get B. So we got 21 times the sine of 21 degrees equal to B. So we can go put that in, type that in together in our calculator. That's 21 times the sine of 21. You're going to get what? 7.5? Let's check it. 21 times the sine of 21. All right. Type it in correctly. 21 times the sine of 21. 7.5. All right. Here's B. So B is approximately 7.5 units. And you've solved it. So you've got all three parts. So you needed A, you needed C, or you had C, you needed B, and of course you needed angle A. So two sides were missing and an angle. So you're given half of it. You were given two angles and a side, right, in that triangle. We call an angle side triangle. We had to find the other three parts to solve it. So again, find all 6 parts. Let's look at example B here, 6B. What do they give us? Let's write in the given information. we're given side B. So B is 110 units in length. We're also given the hypotenuse. It's 380 units in length. And, of course, we're given angle C, which is the 90-degree angle. So we got to find out what A equals. We've got to find out what angle A equals and angle B. So we need, again, angle A, we need angle B, and we need side A. That's what we're looking for. So if you want, now we could use geometry and go ahead and get side A if we need to, right? So again, different ways to go. To get that, I'm going to go ahead and find A. So we have 2 or 3 sides. Let's use the Pythagorean theorem. Use some geometry to find that. Then we'll introduce our trig and get our angles. So again, we know that the hypotenuse squared, c squared, 380 squared, equals a squared plus b squared. All right. So again, as we're looking at that, we got to solve it. So we'll go ahead and subtract 110 squared over to the other side of the equation. So 380 squared minus 110 squared equal a squared. And then take the square root to get a. Principal roots. And we'll have what we're looking for. We'll have a here. So a is equal to the square root 380 squared minus 110 squared. So let's go put that in our TI calculator. We'll find side A's length. So second, let's clear out our last problem. So second, x squared key is our square root. And let's type it in together. 380 squared minus 110 squared. Hit the enter button. 363.7. Rounded to the nearest tenth. 363.7 units. There's side A. So there's 1/3 of our solution. Now let's go ahead and get the angles. Let's find angle A. Now to find angle A, let's use a trig function. Now I'm going to use the given information. I'm going to use the adjacent side, and I'll label it in here, and my hypotenuse with angle A. That's the adjacent. So finding A, we can go ahead and do that now. Let's put it in black. So we have the cosine of angle A equal to adjacent over hypotenuse. So that's equal to what? B, which is 110 over 380. Right? So yeah, cosine of A equal 110 over 380. Now, to find A, right, we need to use inverses. So A is equal to cosine inverse of 110 over 380. So to find the angle measurement, we're going to use the inverse properties. And we can go type that in and get angle A's measure. So let's go ahead and find that. Let's pull it up. So what do we get here? So cosine of A, again, 110 over 380. All right, let's type that in. So second cosine of 110 divided by 380. And we type that in with A, right? Using the adjacent side. That's 73.2 rounded to the nearest tenth. That's 73.2 here with that one. Right. So with A. So again, using the cosine function to find the angle A there, adjacent side. So that's angle with A's measure. And with that, again, adjacent over hypotenuse, which we plugged in. So A equal to 73.2 degrees. All right. So now we've got 2/3 of the solution. Let's go ahead and get the final measure. So now we've got to find B. And to find B, we know, again, all three must sum to 180. So use some geometry. So 180 minus the sum of the other two. So angle A, which is 73.2 degrees, plus angle C, which is 90 degrees. All right. So we go ahead and put that in there, and we'll simplify it down. As we do that, we have 180 minus, what's 73.2 plus 90? Well, as we add those together, we get what? 163.2 degrees. And as we subtract that, we get what? 16.8 degrees. So 16.8 degrees is angle B. So now we've got all three measures. We found angle A, we found angle B, and we found side A in that one. So we've solved that triangle. All right. And let's finish off this set. Got one more problem. Let's look at problem 7. Let's do an application of using right triangle. From a boat on a lake, the angle of elevation to the top of a cliff is 13 degrees, 17 minutes. So instead of a decimal, they're using DMS notation, right? Minutes and seconds. Remember, 60 minutes a degree, 60 seconds a minute. So I've gotten rid of the decimal and converted over here into minutes. And that's fine. We can leave it in that form. And we can even use it in our calculator. Our calculator knows DMS notation. It says the base of the cliff is 2,972 feet from the boat. How high is the cliff to the nearest foot? All right. So let's go ahead and draw a picture. Let's get a visual of what we're looking for. Now we want to know the height of the cliff. All right. Now let's draw in this cliff here. So I'm going to draw on this cliff here as my vertical. All right. Here's the cliff. All right. And we want to know its height. All right, X. How tall is it? And we got a boat sitting out here on the lake. Let's draw in this boat out here. And here's my boat. And the angle of elevation was given. So the angle of elevation to the top of the cliff, and I'm going to draw that here, this line of sight to the top of the cliff. All right, and of course the horizontal. We know that angle is the angle of elevation, right? Angle between your horizontal line of sight. So that's 13 degrees and 17 minutes. And it says the base of the cliff from the boat. We can go ahead and label that. That was given to be 2,972 feet. All right. So with that said, we've got this horizontal and vertical that we've drawn in. The cliff standing vertical. And, of course, going out there on the lake horizontally, we've got our 90-degree angle. So we want to find X. Well, what can we use, trig function-wise, that incorporates the two legs of this right triangle? So we got to find X, right? X is the height of the cliff. And to do that, we know we can use the tangent function. So find X. So that implies tangent. So the tangent function, well, the tangent of 13 degrees, 17 minutes, would equal opposite over adjacent. Opposite divided by adjacent. And then we solve it. Now, as we solve that, we just multiply both sides by 2972. So let's go ahead and do that on both sides of the equation. So we can solve for X. All right, so that implies 2,972 times the tangent of 13 degrees, 17 minutes is equal to X. All right, so we could type that in. Now on your calculator, let's pull it up. And I'm going to pull up a different version. So I'm going to show you the DMS notation. 2972 times the tangent. Now with that said, I want you to go into your mode key real quick. All right, my mode is in degrees, so make sure again it's in degrees, which it should be from my previous problems. We got 13 degrees. Now remember, this is in your angle menu, so you're going to hit the second button and your apps key. And command 1 is degrees, so we need to specify degrees. And then we have 17 minutes, so you're going to go back in the angle menu, second app key. Command 2 is minutes. All right, and if you ever need a seconds, that's above the plus sign with the alpha key. You'd have to hit alpha and plus. But I can hit the enter button, right? And out comes 701.6. So rounding to the nearest foot, which it has to do, nearest whole number, we got 702. All right, so that implies x approximately 702 feet. There's the height of the cliff. All right. So again, using right triangle trig, right, make that problem easy. Get a visual. Want to get a picture of what you're looking for. So we'll stop there and continue. That's a good place to take a break. We'll continue on.